All right, thank you. Good afternoon, everyone. Um, Welcome to this talk. Let me appreciate the PHP Day community for a great conference, and it's a privilege to be here to speak in front of everyone. Um, I think this is my second time of doing this, a talk in front of PHP developers, and I get nervous just because there are a lot of people seated here who probably know more than I do. So just follow me as I go on. All right. Um, Building fast APIs and middlewares with Mezzio and Swoole. My name is Babarinde Odewumi. I'm from Nigeria, and I live in Nigeria. I'm a senior software architect at Apache Systems and also a founder of Insurability. I'm a husband of one, father of two, and I am a believer. So basically, I lead a team of designers, front-end and back-end devs, and we build systems that makes the life of people a bit easier, um, basically. And we try our best to make sure there are no the products that we deploy don't have as much bugs, and hopefully we'll get to a point where everything just works seamlessly. Of course, currently we design end-to-end softwares for digital insurance companies in Nigeria, and in some spare time, I make contributions to a project, a Docker scheduler for Kubernetes. In this talk, we'll be talking about Mezzio, Swoole, and the combination of Mezzio and Swoole together. So a quick show of hands, how many of you have heard of of Mezzio? Okay, thank you. And how many have heard of Swoole? Okay. All right, so I think we can have a good mix of this. All right. So why do APIs need to be fast? We live in a digital age where everybody wants to click and move, and everything has to be as quick as possible. Nobody wants to wait for the ball to keep rolling and rolling, and attention spans gradually reducing. So everybody wants things fast, fast cars, and all the stuffs. And of course, modern web front-end frameworks also are also tools that we personally believe that I personally believe that um, there are a lot of things that modern front-end frameworks, Angular, Vue, React can do that PHP may not be able to do. Of course, maybe because I've not just gotten to that point. And of course, lastly, APIs need to be fast because of the consumers. The customers are rather impatient. So for us, we use Mezzio and Swoole to build private APIs that our front-end applications consume, and we also build public APIs that other clients that are external can also consume as well. And of course, lastly, of course, we also use Swoole for Mezzio and Swoole for long-running jobs and tasks as well. So let's talk about Mezzio. Um, I hear that Mezzio is also is an Italian word. I don't know. Perhaps that's one of the only Italian words that I know, and it talks about something in the middle. I may be wrong, but that's what I've heard. So correct me. Am I right or wrong? Ah. All right. Well, it sounds Italian anyway. Okay. So what is Mezzio? So Mezzio really allows you to be able to build these lovely PSR-15 middleware applications. You can create these middleware applications using layers, as many layers as you want, so that you have a nice architecture for your project. This came out, used to be a project called Zen Expressive. If you're familiar with the Zen world, the Zen Framework 1, Zen Framework 2, 3, and all the iterations that have come up. So Mezzio is just a fork out of that. Fun fact, my first Zen Framework 1 project, the get started, I think I spent about 2 days getting started on it. Yes, so Mezzio uses PSR-15 middlewares, and it largely consumes PSR-7 messages. We'll talk more about that. You can create your route requests for the middleware using fast route, Aura route, and Laminas router. It also allows you to do dependency injection with PSR-11 compatible interfaces. Laminas Service Manager and the likes. Then, of course, you can use templating with twigs, plates, the Laminas view. Then you have error handling with whoops. I don't normally use the templating side of things. My team basically just writes the API stuff, so I may not have a good dive into that. But again, this is just a talk to introduce you to what the possibilities are with Mezzio and Swoole. Of course, you have to go back and dig deep and deep and deep. So let's talk about middlewares. So basically, a middleware is a code that exists between your request and the response. And it can take basically an incoming request. A request is coming from the web. Your middleware can take some actions on the request and return a response back to whoever is asking the request, or delegate and hand over to the next middleware on the queue till you run out of middlewares and you can get a response back. So middlewares naturally will return responses. So with this paradigm, one of the things you can do is you can build a nice, neat workflow engine where you have middlewares that you can have when a request is coming. You have one that handles your authentication, another one that handles access control, and so on and so forth, like that. So for one of the values is that it allows you to have building blocks where you can compose components as well. The lightweight, it allows you to organize your code correctly, neatly rather, and you have middlewares that you can reuse for multiple endpoints, and you also have interoperability. So I will be showing a lot of code just to be able to explain some of this stuff. So please bear with me. I won't be typing the code. I just have them on the screen. So this is the PSR-15 request handler interface. Basically, it has just one method, which is the handle method, and it expects a server request interface, and it will return a response interface. The middleware interface is also similar, not similar, but there's a middleware interface that PSR-15 also defines, which has a process function, and the process function receives a server request interface and the request handler interface, which was the one we showed earlier, and will always return a response interface. So basically, when a request is coming into the application, the request would go through each of those layers and middlewares and do one or two stuffs and hand over to the next one. In many cases, it is expected that your middleware you would hit the routed middleware, which is the request is matching the route middleware, and resolve and do whatever it needs to do and give a response back. In some cases, when there is no matched route, the request will travel down to the last part of the pipeline and return an error response, normally a 404 or what have you. So just for the sake of demonstration, you have a sample pipeline, and somewhere in line, so you have different middlewares in this pipeline that would do one of two things for every request. Then you have the dispatch middleware interface, which actually matches your route and do all the things it needs to do. If it can't find it, it will come to the problem details found handler or the not found handler, return a 404, and you can do all the things that you need to do there. So those are the basic stuff on that. All right. So let me just a sample of what we have. I will just run through. It may not be pristine on production ready code. Just forgive me. It's just for the purpose of demonstration. So so you can define basically a post, which is HTTP methods. You have post, get, patch, put, and what have you, are those lines. And this is a sample user route that is a sign-up user. Then I have three other routes that are defined here. But interesting, what I'm able to do is, if you look at line 6 of that code, I have a find user by email. I will talk about that. And I also have that same middleware used in line 17 of another route and in line 23 of another route. And one of the things that this allows us to be able to do actually is that, for example, in this route is saying to sign up a new user. So assume you have a user that has an email address and phone number and what have you. And what you want to do is you want to check the email address. If the email address, so find user by email just runs a simple gets your post data, do some assertions, find the email in your database, and if the user is available, is going to basically call the next handler, call the handler to handle that request and pass delegation to the next middleware. Mezzio also allows you to be able to add attributes to the request for the next middleware. So you can call request with attribute, define the FQ, the full qualified class name, and the object. So in the next middleware, you can access that variable as well. Then, of course, if you can't find the user, you can just tell it to go to the next middleware. So what if we proceed, in the first case, after you found the first, you've done the find by user, the next thing is to create the user. But interestingly is that when I'm creating a user, the first thing I want to be sure is I want to be sure that user's the email doesn't exist in the system. So if so in the next middleware, what I can do is I can get the attribute from the previous middleware, and if that user exists, then I can throw an exception because it means that user currently exists in my system. And that's one of the beauties. Then if it doesn't exist, I can do all the other things. And I can now pass that handler, create another handler, and send the other handler to call the handle method and pass another attribute to this. Now, in the case where I am, in the other case we have here where I have called this find by user email. My check password basically is just, I want to log this user in at this point. So, strangely, the up button goes backwards and the down button goes forward. So I'm trying to adjust. Okay, maybe I should do like this. All right. So in the next middleware, now when I'm checking for the password, I want to be sure whether that user exists in this case. If the user doesn't exist, then I can throw an exception at this point and say, this is bad, and do whatever exception I want to do. So I have a middleware that can help me to just find the user by email, and it doesn't need to know what is going to happen to that user. Any other middleware that comes after that can now interpret the results, and we can now drive on with that. I should also mention that you have callable middlewares. Instead of creating a whole file for the middleware, you can actually, create this callable functions within your routes to define basically just the same signature as the PSR-15 middleware interface describes. You can do everything you need to do, and you can still return you can call handler handle to hand over to the next middleware. So basically, to get started with Mezzio, you can just do a composer create project and use the skeleton project as well. Mezzio also provides other middlewares that you can use for problem details. So if you want to return a response, there's a problem details standard that can help you return your error responses in structures that will be identifiable. Then you have cause, which is also valuable, authorization, and all the things that you have there. All right. So let's go to Swoole. Well, I really don't know how to pronounce it, but I just call it Swoole. So you can call it Swoole, or doesn't really matter. All right. So what is Swoole? Swoole is an event-driven asynchronous coroutine-based concurrency library with high-performance PHP. So one of the things you can do with Swoole is you can create HTTP servers, you can create WebSockets, TCP servers, UDP servers, coroutines, and many, many other things. There are two directions this project is going. One is Swoole, the other is Open Swoole. I won't get into the details of that, but feel free to use anyone you want to use. All right. So in layman's terms, in the traditional PHP, Apache, and what have you, whenever you run an HTTP request to the server, what happens is that a PHP process will be triggered. Your whole application is bootstrapped and loaded in memory, and the request is processed and response is returned, and everything is gone. Then the next request, you have to bootstrap the whole framework and what have you in memory again. So you have that done over and over and over again. And there are some tools that can help reduce the bootstrapping process, but a lot of times the biggest work that your application does is actually bootstrapping this code and storing it and doing what have you. So What advantage does Swoole have over this is similarly when you start up your server the first time, the application is loaded in memory, and Swoole is able to dispatch web workers, process your request, return your response. But the next time the application is going to be hitting your web server again, the request is hitting your web server again, I beg your pardon, it will use that state that is in memory to do every other thing that it needs to do, which is one of the reasons why it makes it very, very fast, and we'll talk more about that. So basically, this is the design of Swoole. This was copied from somewhere on the internet. So you have the manager, the Swoole manager, which is responsible for managing the event workers or web workers, which are responsible for managing web requests. Am I speaking too fast? I'm just fine. All right, because when I'm nervous, I speak quite fast. So, all right. So you have event workers, and which are also web workers that process the web request. When they come in, then you have task workers, which you can use to process or manage long-running jobs. All right, so Swoole runs this main process, which actually would bootstrap your application and keep it in memory so that your subsequent request, will easily just flow through and honor those requests and move on. So the HTTP requests are handled by these web workers. They were called event workers in the diagram. And what Swoole does, it forks out the contents in memory for the main process for each one of those workers. So each worker has a copy of that application in memory. And it's also isolated. Each worker is independent, but each one of them can only handle a request at a time. So you have those workers that will have a copy of that, of the application in memory, do what it needs to do, and is also independent. So everything that happens within that worker, in most cases, does not affect the other workers as well. So you have that isolation, sort of. So it's important to know that many times where you have more traffic, you need to have more workers to be able to manage the load that will come from your business. So this is a sample of how to create an HTTP server on Swoole. So you have these functions, callback functions that you can define on start, which would basically just start the server, and you have on request. So when a request hits the server, it can do anything you need to do. This is just a simplistic model of this. Then you have the same thing for WebSockets. You can also define those callbacks on start, open, message, close. Then you can, start the server. Then you have TCP servers as well. Same thing. You can have those running. Then you have these things called coroutines, which really make the applications fast. So coroutines allow you to be able to, make calls. Oops, sorry. So these calls can run in concurrently. These two calls can run concurrently, and their results can be joined together, and you can all do that. So as an example, you can run. They have this clients, even though there are better ways of doing this now. You have this MySQL clients, coroutine clients that they provided that can allow you to run concurrency 10,000 requests to read data from MySQL, and it takes only 0.2 seconds. So this gives you that speed, of course. But now there are newer mechanisms that they've provided, but this is just for the sake of examples and demonstration. All right, so more about coroutines. You also have what you call channels. Channels basically are data structures that you allow your coroutines to be able to share information with one another. So you have two coroutines. They can gain access to a channel if you create a channel, and they can exchange data in that channel. You have wait groups, and wait groups primarily are so if you are running multiple coroutines together, you can define a wait group, which also uses a channel to allow all your coroutines to finish. Then you create a wait, a sort of wait area where after all the coroutines are done executing, then your code can now continue. Then barriers are also similar to them, but the designs, the structures are different as well. Then you have connection pool. So this connection pool is useful because you can now create MySQL pools, PostgreSQL pools, Redis connection pools. You have pools of connections as well. And interestingly, it's one of the things they also do is it can also help you once connection times out. It can restart and re-enable reinstantiate connection as well. All right, so more stuff about you have. You can use it on Docker, so you can play around with Swoole on Docker. There's this GitHub repository that has many examples that you can you can work with. And of course, it also works on Xdebug. I think version 5.0 was the one. There was an Sdebug a while back, but then eventually, I think version 5.0 was now able to work with Xdebug. So I know the Xdebug boss is here. So all right. So let's combine both of them together. Just simple examples to combine Mezzio and Swoole together. So basically, installing Swoole is either used just from run pickle install on Linux, and you have your Swoole installed. You can call Composer to require this in that project, and you can basically just start your Mezzio server, like your Swoole server, that way. Now, configuration. So some of the things that you may need to do in your configuration is that you will want to enable coroutines. So those are configurations that you can define to allow you to be able to use coroutines in your application. You can define configurations for your HTTP server as well. The host, the port it needs you to run. You can define the number of workers the web workers you want to use. You can define the number of task workers that you want to run. I will talk about tasks shortly. Then you can also enable coroutines in your tasks as well. So these are configurations. There are many configurations. I just picked a few examples to talk about here. Then, of course, when you start your Swoole server, this is something, it looks like this. All right, so this is a simple example. I have a system that basically sends messages, should send an email to someone. And normally, I get my user attribute from whatever middleware I'm coming from, and I can call this coroutine create function to create a coroutine and send the mailer should send my OTP. So what this does is that by design, normally if the coroutine wasn't there, we have for the send OTP to go connect to SendGrid or whoever, and when it's done, that's when you can return a response to your client. But with this coroutine, what it will do is that it will put this in the coroutine and return a response 2012 to your client. And eventually the mail will send, but nobody checks the time when the email delivers. We eventually will deliver, but you don't just want to hold everybody back on this. So this gives you the flexibility to quickly return response back to your client without wasting so much time, and the email will eventually send itself out on that level. Okay, now so many times when we write code, you have this long-running tasks, things that may take undefined amount of time, and in some cases you may have to use message queues and other tools that are available. And so one of the things that I mentioned task workers when I was talking about Swoole, and there's a nice integration for us to be able to work with, where you can delegate a task to go and do something, and you really don't care when it's done. Or you should care, because in case you run out of task workers, that may be a problem, but normally you shouldn't take. So this is a simple example. So I have this middleware called log execution image. I just get some attributes, do some stuff, create this document, and I need to, after I get this image, I need to do something with it. So this is how to call the task. So basically I just say server.task and pass my model to it. I really need something else to happen beyond this. So once I have done that, I just needed to show you this to be able to explain a few things. In the setup for Mezzio, you have this concepts called delegators. I may not need to talk about factories or invocables and the likes, but for delegators, what happens is that when you use a delegator mechanism here, it actually decorates this HTTP server class before the full object is returned. So this is an example. In this task delegator worker, what I'm doing is I'm hijacking that server object and defining certain tasks that I want it to run. So in this case, I'm saying on this task, do run this task worker, and on finish, just do basically nothing. Then I'm returning the server back. So the way Mezzio will wire this up. At the point where it needs to create the HTTP server object, it would have wired this test worker in. So anytime I call server task, it will call the invoke. It will invoke this server, pass the model to this, and I can now call. In this case, I have a recognition service on Azure or wherever to do an image recognition. So by delegating that responsibility to the task worker, it will do it on the background and get it done. And my user doesn't need to know that I've called an image recognition system independently and all that. So these are tools that make Swoole very interesting with Mezzio. Also, one of the things that you can do is that you have this, you can also use cron tabs with Swoole. This was inspired by an article that was written by MWP. It's difficult to pronounce his surname, but I'm sure some guys will know him here. So he wrote this article about how we can, I think his name is Matthew. So he wrote this article about how we could use create cron jobs. So normally everybody will have cron jobs. You want to do something at a particular time of the day, or you want to do this at night or midnight, or so. This actually allows you to be able to. This is just basically an array of cron jobs, and I can define my schedule, my cron schedule here, and I can define an event class at this point. So for Swoole, one of the good things is that it comes with this timer mechanism, because there is this. It lives in this event loop, and so what happens is that I can set this timer. So there's this listener definitions. This is the function. I can create this timer tick that every minute I need it to run through the cron jobs, the list that I have from here. I can run through it every minute and check. There's this cron expression library that can pick that string and check if it's a valid cron job and check whether that cron is due. So if it is due, it will basically dispatch the event class that is defined here. So for this event class, I have okay. So let me also mention. So I have these delegators again. I had explained delegators earlier, and what it will do is whenever I need to create this numbering class, basically, which is from this factory, this deferred service listener delegator will take responsibility for it and wrap itself around it so that it doesn't run. It's actually deferred. So I can define some mappings here. So also, I know that anytime I want to run, anytime I see the annually event, I want to do this. I want to run whatever it is that is going on here. So there's this listener setup that you can have events classes mapped to workers or classes or factories that would eventually do whatever things I needed to do. So as an example, this is what my numbering looks like. So it's just a regular class. I can get my object manager and do anything I want to do inside here. So one of the beauties is that at the point where you have that event triggering at any time of the day, I can have as many of them. It will come and invoke this class, this function, and do anything I needed to do here. So it allows you to be able to create real cron jobs as if you are on your server, and it will, based on the time, call the right functions or classes as you need to do, and it will execute that for you. I put some links for the benchmarks because benchmarks performances are often long reads, so you can check them out. The slides are also going to be available online as well. It will show you benchmarks against regular PHP and and Swoole. Benchmark different types, Nginx with Swoole as well. You do various benchmarks for it. So the links are there. You can also check them online. There are quite a lot there. But everything is not all rosy, obviously. You have some things you need to consider, actually. Excuse me. So it's possible if you have long-running processes, you may you may run out of workers to process those jobs. So you need to understand the kind of transactions that you're managing and provision enough to be able to manage the load. Then you need to actually avoid using sessions because obviously everything you create at the point where the instance is when it's instantiated, everything resides in memory. It's important that your services must be stateless. They must be stateless because, and these were lessons that I learned the hard way. There's some, I will still talk about them in the next couple of slides, where an object has been instantiated somewhere you didn't know, and after some time you found out that it timed out, it died, and nobody else can use it again because everything was used in memory. So there are mechanisms to be able to help you create the objects when you need them, which we'll talk about factories and all sorts of stuff that we can look at. So those are some of the issues. We ran into some, and this is an example. We have this Azure blob service that you are trying to call, and somebody sending an image, you shoot it to Azure, and so one of the ways we're able to manage this is to avoid any timeouts on this connection, on these calls. We decided to wrap this inside a factory. I don't think this is a design pattern though, but it's just called a factory. And what it does, it wraps your factory in a factory in a sort of callable function. So you, at the point where you need to, so this is what our service looks like, but it is actually at the point where I need to call this, that's when I instantiate this by calling this. So it gives me that flexibility. So whenever I need to upload, I just call this client, instantiates the blob resty client for me, and then I can now upload whatever I need to upload, and I'm done with it. The next worker will also do the same thing. At the point where it needs to make the upload, it will create the factory, create the object, and do all that it needs to do. All right. So this was one of the other issues that we ran into. Is also we use doctrine, and well, maybe it's really not about doctrine, but it's about instantiating the object manager at the point where, if you're not careful, your connection to MongoDB can time out, or your connection to any database can time out. And so one of the things we needed to do was to also have this delegator sort of to be able to help manage the object manager. So when the object manager is being created, we wrap it into this object manager. So we have these decorators that help us hold that object as at the point where we need it. So you have our document manager decorator, which basically helps create the object managers at the time where we need it. And we also set it here. So it also check if this is opened, and if it is closed at this point, we can tell it to open it again and instantiate a new one at this point. And so we had to also create these wrappers. Interestingly, these wrappers were available on, these decorators were available for the ORM, but not for the ODM. So we needed to provision this. And so basically, at the point whenever you need to call this, you have these wrappers are the ones that will do the calls for you to manage any issues that you may likely have there. And so at the point on our own system, we're able to, at the middleware level, we can actually track this to know whether our document manager is alive or not, and do all the things it needs to do. We can close it and clear it and do all stuff without creating any issues. All right, so we have some resources here on the documentation site of Mezzio. You also have the English version for the Swoole documentation. It used to be in Chinese, but some people did great work by translating it to English, and it really is very detailed content. I mean, it has much more than I could have spoken about. Then, of course, I'd mentioned Docker and Swoole and also other documentations on that. All right. So I think that should be the end of my talk. Thank you very much. the slides are on the link. And okay, you can please rate the talk on joined. Just rate it and give us positive feedback. O-
Okay. Always the answer. Okay, thank you again. And any question? No? One there. Can you jump? Over there. Can you throw the microphone maybe? I throw myself. And then we have one from home. Okay.
Hi. What happens if you get a 500 error? Does all the instances crashes, or what happened?
So if you have a what the manager, in the diagram I showed, there's this manager. The responsibility of the manager is to recreate a new web worker at that point. Normally, if the middleware is returning a 500 error, the middleware itself is returning 500. That's not a problem necessarily. So, but the job of the manager is to be able to recreate new workers, to be able to make sure, if you say you have 8 workers, if one crashes accidentally, we'll create a new one. And yeah, so that's what the manager does.
Any other question here? Physical questions? No. I have some remote questions. Okay. So great talk. Do Swoole coroutines use fibers or, don't know, something else? Is it by any means harder or different to use Xdebug in a Swoole environment?
Okay. So first, it doesn't use, to the best of my knowledge, it does use fibers. It has I think it's a C extension as well, and it has its roots in all the details. I mean, like I said, there are quite a lot of other functionalities that Swoole has process management and tables and so many other stuff. So the other question is it easier to use Xdebug in Swoole than in other environments? So I actually didn't used to use Xdebug until I started using Swoole, because it became necessary to really manage, to understand what is going on. So yes, I mean, from my perspective, it will be very difficult to work with Swoole without a debugger, and Xdebug is really brilliant in managing that. Of course, in one other challenge that Swoole poses to developers is that when you change your code, when you're developing, ideally you should just call the endpoint normal and everything should work. But in this case, you need to restart the server again so that it can. Of course, there are other tools like hot reload that can allow you to help you reload that. But for many of us, when you've gotten so used to it, restarting the server is really the least of our worries on that. Yes, so Xdebug, brilliant with Swoole.
Okay. We have other questions from home? No. From here, no. So I think we can make another round of applause. Thank you.